We're going to do number 61. Remember, we're working, our objective today is to identify which equation. We're doing two parts. Identify which equation we're going to need in every problem. We're not going to use one equation for all the problems. We're going to be using multiple different equations for each problem. So that's what we're going to be doing, and then we're going to be plugging in the equations to solve for whatever the question wants us to find, whatever we're looking for. Okay, so we're going to do number 61. First, what I want to do before I go into the detail, I want to see if you guys can identify what equation before we dive deep into the detail. So pay attention to the details I'm going to be reading, and I'm sure you know which ones to eliminate. And go ahead and copy and paste all this, just so as we're going through it, we can just eliminate the ones that don't make sense. All right, so are you guys ready?
Yes.
A water drop falls down from the roof of a house during 3 seconds. How high is the house? Okay, what are some clues in this question that helps me with process of elimination?
3 seconds.
All right, what does the 3 seconds have to do with anything? What can I do with that fact?
That you need to use an equation that uses time.
Okay, we need the equation that uses time. So what can I eliminate? Which equation can I eliminate that would not work?
The last one.
Okay, I'm glad that I'm hearing. So the last one is going to go because it has nothing to do with time. Let me keep going. So again, let's read it again since we eliminated one because of time. A water drop falls down from the roof of the house during 3 seconds. How high is the house? So based on the fact given to me, which equation might not work? Process of elimination.
The first one.
The first one. Why do you say the first one?
Because we're trying to find how high, and that's finding the speed, the final speed or something.
Well, how high has to do with a distance. Remember, how high is the house, not how fast. Okay, if it has to do with speed, we're looking at how fast or how quickly. Hence the question over here that says in the bottom, how fast. That's how you know you're looking for speed. Velocity is basically a speed with direction. That's why you have to be careful. How high has to do with distance. It's like saying how much of something. How high is from point A to point B. You can't figure out how high without having 2 points. Does that make sense? The first one has to go because there's no part of the first equation that gives me height. There is no final position or starting position. So the equation that I know I'm going to be using is this. So let's go back into details and put in what we know. So what facts do we know? We know time is 3. What else do we know?
The acceleration.
We know acceleration is
9.8.
negative 9.8. Why is acceleration negative 9.8?
Because we're trying to find the height.
We're finding the height. But also, why is it 9.8? What is the clue in the sentence that tells you acceleration has to be negative 9.8? Because that's that part of free fall. Drop
falls down.
Thank you. Drop falls down. Those are key words that tells you acceleration is negative 9.8 due to gravity. What other facts do we know? Look at the variables given to you. Do we know VO? Do we know XO? What do we?
No, we don't know VO or XO.
Do we not? Are you sure?
We know XO.
We know XO? Okay, what's XO?
0.
Why do you say XO is 0?
Because it's starting at rest.
What is it? What object are we talking about?
A water drop.
The water drop.
The object that we're focusing on is important for you to know. The object is water. The water drop. That's the object that we're looking at right now. So if it helps to write what object you're focused on, it helps you decide where the object starts from. What was the speed of the object before it started falling down?
0.
Okay, 0. So that means we know starting velocity. It's 0. There is no speed to it because it was just a water drop chilling on the rooftop until it starts sliding down, and the next you know it's dropping. Okay, like a rain. It just drips. Okay, and what are we looking for in this equation?
We're looking for XF.
We're looking for XF. We don't know what the height of the house is because of the drop. Let's go into higher thinking. How can this equation help me outside in the real world?
It can help you, like say if you're walking and like you're seeing a water drop and it drops, like while you're walking, like it drops in front of you or on top of you. Maybe like you could basically see it.
Yeah.
You could solve the problem basically.
So here's a fun fact. What if I was a carpenter? How can this equation help me as a carpenter? What is
what?
if I was a carpenter? I say carpenter. If I was building a house, why would this equation be able to be useful? Why would knowing something like this be useful?
Because you would know how high the house would be and how the water drops in 3 seconds. So like it might help build the roof.
What is the point of knowing how high? The point, what am I doing when I'm trying to figure out how high? It starts with an M. You're doing a measurement. Some of you who are like, I don't have a measuring tape. Okay, you don't need a measuring tape if you're able to figure out something like this. So let's say you're on top of a rooftop and you throw a doll down to the ground. You can use an equation like this and the same exact equation that we're working with right now to figure out, okay, well, how high is this building so I know how long it'll take for me to actually go get this doll? What's the fastest route? Some people might say jumping off the rooftop is the fastest route. I mean, if you can land on the ground with both legs, good for you. But if you think, it's pretty high, let me just walk down the stairs. In the end of the day, all this is showing you is how to measure without a measuring tape. This is how you measure without a measuring tape. So finding how high is exactly how people say, okay, I don't need a measuring tape right now. I don't have a measuring tape. And over again, we keep practicing these equations, but know that these equations in real life are created for a reason. Okay? Since we're looking for how high, we're going to plug in what we know. We know O is 0. XO is 0. V is going to be 0 times times where T is at 3 plus, I'm going to just copy and paste it to make my life easier, and you could do the same if you need to. I'm just going to copy and paste it as this is step 0 for us. Why is it step 0? Can you remind me? Because we're just plugging in. We have not done anything yet, literally, that changes what it originally was. If I take away all these numbers and replace them back again with the actual variables, it's still the same as what I have up here. That's why it's step 0, because only thing that changes the numbers, but the variables are still there. I haven't gotten to the point yet. So let's go into step 1. Go ahead and tell me what to do first. Okay, so I'm going to get rid of the zeros. I know that 0 times 3 is going to be 0 anyway, so this entire equation here goes. Here's a pattern that I noticed. Let me see if you notice that pattern. What's the pattern when you're looking for a height and XO and VO isn't given? What does the equation start to look like? What part of the equation? Maybe I should reiterate. If XO and VO is 0, what part of the equation do I need to use?
Time and acceleration.
That's it. Half. I'm using only this part. The last part. Half acceleration times time squared. Because XO and VO is 0. This is how you work faster and smarter. Okay? If you already know 0 and 0 here and you know the equation, all you have to do is just realistically start with half of negative 9.8 times 3 squared. Make your life easier. That's if you feel like you're capable of going to that point. Some people are not there yet. Take your time with it. All right, step 2. What am I going to do that makes sense? That's easier for me and it makes sense. What makes sense to make it easier for myself, I'm going to do my square root. What's 3 times 3?
9.
9. Okay, I wrote down my 9. Now what? What's going to make sense for step 3?
9 times negative 9.8.
Okay, 9 times negative 9.8. Remember, that half is a whole different changer because technically that half is division. And if we're thinking about PEMDAS, multiplication comes before you divide. That's why you don't do half of 9 and then multiply negative 9.8, as some of us were thinking of doing. Because remember, when you're working with half, you're technically dividing. And if you know PEMDAS, division comes after multiplication. So negative 9.8 times 9. So negative what?
Negative 88.2.
Negative 88.2. Awesome. So now that I'm done with the multiplication part, technically I have negative 88.2 over 1. Why do I put over 1? What am I doing when I put over 1?
Division.
I'm dividing because realistically, I'm going to show you on the board why. I'll repeat that again. The moment that you're multiplying by a fraction, you're making the number being multiplied by that fraction a fraction. Does that make sense?
Yes.
So it becomes, because you're multiplying by a fraction, the negative 88.2 becomes a fraction by putting it over 1. So when you cross multiply, the ones cancel out. So all you're left with is negative 88.2 divided by 2. What's negative 88.2 divided by 2?
Negative 44.1.
Okay, could someone confirm that that is truly the answer, please?
Yeah.
This is true.
Okay, so negative 44.1. So now without a measuring tape, I know that this house, based on how the water fell, is about 44.1 meters high. That's high, because if I know the length of 1 meter is the size of my arm when I stretch it out in front of me, almost like a nice hug, I know that this house is a pretty big house if it's 44 meters high. It's a pretty big mansion house. I would say, so I can make the assumption, because it's 44 meters high, it must be like a nice school building, like a big house. It's not a tiny one-level house. Does that make sense now? So realistically, all these equations are doing in this moment is, again, teaching you how to make assumptions or create theories using facts. That's why we have these equations. You can create actual theories, because if I say this house is about 20 meters without the proper facts to prove it, I'm going to either just agree with you even if you're wrong, or disagree with you without any way to prove that you're wrong. But now I can prove that if you told me it was 20 meters, here's why you're wrong. So you want to learn how to prove people wrong? Here you go. Here's what physics is here to do. Teach you how to prove people wrong.